Okay, so 4.4, here we are, matching equations and graphs. So we've talked a lot about tables of values, we've talked a lot about graphs, we've talked a lot about characteristics of the graphs, characteristics of the equations, how to write them in words. So now we're going to focus on the connections between the tables of values and the graphs, and we're going to be matching all sorts of different things. So just a further explanation of graphs and equations, okay? All right, so in your notes here, we have a little situation. It's called an investigation, and this is the setup of this investigation. It says, Bruce, Monica, and Sari participated in a 5-kilometer walk for charity. Each student has a different plan to raise money from his or her sponsors. The following graphs show how the amount of money a sponsor owes is related to the distance walked. So have you guys ever done anything like this before, like Terry Fox Run or something like that, where you get pledges? I don't know if this happens as much anymore. It used to be when I was a kid, like we would have a readathon or we would have a something, and people would say, hey, I'll give you $1 for every hour that you read or something, and it'll go towards the library or whatever it is you're raising money for. Sometimes, if you walk every kilometer, I'll give you $5 or something. So that you take pledges, and that's how people would donate. So it's kind of a fun way for people to kind of encourage you to do something healthy, whether it's walking or reading, and then they would be able to donate based on how well you. So you kind of earned your donation just a little bit. And it turned out when I was a kid, we used to do that kind of stuff. We would walk as a class, or we would read as a class or whatever, and we would kind of all contribute, and it was a bit of an activity for the class, and we knew we were doing this for a good cause. So that's the situation here. So they're going to go on a walk, and they're getting pledges from sponsors. So a guy like me, maybe you would come to me, a person in your community, and you would say, listen, we're raising money for such and such charity, and we're going to do a walkathon. We're planning to walk about 10 kilometers, but it might be a little less, it might be a little more. Would you pledge to donate based on how much I walk on this day? And they would say, yeah, you bet. And so these students have come up with different plans to propose to their sponsors, okay? So let's take a look at it. Let's take a look at each one. So Sari here, you look at the graph, and the money owed is on the left. It's a little bit tough to see that there, I would understand. It's 5, 10, 15, and 20 on the side, and if that is too small for you, I apologize, but I believe this is 5, this is 10, this is 15, and this is 20, okay? I'm still frozen? I'm sorry. There we go. Can you see that now? Unfrozen? Okay. So we see we have a graph that increases. It's a positive slope, which that's good. It makes sense that the kilometers that are walked, the more kilometers, the more money that the sponsor would owe, right? So that sounds about right. Yeah, question? Oh. So we have 0.00. Remember, these are points, right? Kind of 0, 0. So that's this point right here. Okay, awesome. After 1 kilometer distance, so this is distance in kilometers. After 1 kilometer, the amount owing would be $4. So if we go to the graph, we go here over to here's 0, 0. Here's 1. This should be 4 right here. Okay, so that is $4. So this is plus 4 to get to this one. Nice. I'll erase these. So this is plus 1. This is plus 4. Okay, and the x-axis has plus 1, plus 1, plus 1. So that's awesome. And the y-axis, or the y values here, the money owed, is plus 4, plus 4, plus 4. Do you guys see that? It's all plus 4. So every kilometer we add 4. So 4 plus 4 would be 8 right here. Okay? And then add another 4 would be 12. And maybe you can see that we're actually multiplying by 4. Each kilometer is times 4 to get the money owed. Do you see that? Interesting. Okay, so that's kind of cool. That's kind of cool. So if we were to take that and to describe what's going on here from our work in previous sections, you might say it looks like we have D over here. Whoops. We have M, I should say. M is equal to 4 divided by 1. That's the change in the y values divided by the change in the x values. That's 4 over 1 times D. Remember how we started this before? And then you would check some points and you see if there's any adjustments that have to be made, plus or minus. And like we just said, M or D times 4 gives you M. So 4 times D, that's all we need. So you can just change that into simplified just a 4. So it looks like we have M equals 4D. So if we were to describe that in words, okay, describe how Sari's collecting money from her sponsors. Anybody have any idea how you would put that in words? Any guesses there? What would you say?
Sari's she's asking for 4 M's per 1D.
4 M's per 1D. Okay. What units is that? For what?
I don't know.
Does it say?
No.
In the question?
Yeah.
Oh, money. Look at money, and it's in. Look at the unit there.
Oh.
Dollars. So, 4. Okay, go ahead. Say it again. You want to try again?
$4 per kilometer.
Okay, very good. She is asking for 4. That's a weird F. $4 for every kilometer walked. And go ahead and write this down in your notes. Kilometer walked. A good rule is kind of whatever I write down, you should write down in your notes, right? If you're unsure, write down everything I write down. I try not to waste ink here, you know. Everything that I have written down on the notes at the end is probably worth something to look back to and to study from. So she's asking for $4 for every kilometer walked. Excellent. Okay. So what if she walks 10 kilometers? That's not on the graph. Is there any way we could figure that out, how much money the sponsor would owe? If she walked 10 kilometers?
Probably 10 times 4.
It would probably be 10 times 4, exactly, yeah. So what's that? 10 times 4 is? 40. Okay? You guys get it? All right. Is this a linear equation? Is this a linear equation, this one right here? M equals 4D? Yeah, it is. And we can tell because the graph is a straight line, right? And we can also tell that this increase between each y value is constant, and the increase between the y values are also constant. So that tells us it's a straight line, linear. Excellent. Okay, well, let's see what Monica did. So is her graph exactly the same? No, it's not exactly the same as Sari's, right? So there are some different characteristics. What do you notice about the line in Monica's graph? What are there's two things that jump out to me anyways. What are 2 things that are different from the first one?
One thing that doesn't start at 0.
Okay, it doesn't start at 0. Good, it doesn't start at 0, 0. The other one started at 0, 0. This one starts up the axis a bit. Okay, well, we'll talk about what that might mean. Any other differences you can see? Yeah?
It's like, for every bit of the graph, there's a different amount of money.
Okay, for every little, okay, let's break that down. For every little bit of the graph, there's a different amount of money. So maybe I'll add to that, okay? For every kilometer that's walked, okay, these sponsors, would they owe more money or less money, do you think? Now, it looks like, okay, so the amount of money is different. Okay, let's just say it's different. Now, what is interesting about this is that it looks like from the surface here that this slope of Monica's line is greater. Doesn't it look like that? I have a little bit of an issue with that though. Why? Because look at what's happening on the side of the graph here. Tough for you to see, but the graph goes up by $2 for each section here, whereas in Sari's graph it went up by $5 for each section. Like the sections that are labeled on the graph. You see, that was 5, 10, 15, and then it ended up at 20 up here. This one goes 2, 4, 6, 8, 10, 12. So really, this scale's a bit different. So we have to be careful about the slope. Only when you have the exact same scale can you compare the steepness of the lines and say, yeah, this is a greater slope. So we have to be careful. So let's break this one down. So yes, we've got the line starting at a number that's different than 0, 0. Okay, so 0, 3. Well, that's interesting. Okay, that's interesting. What do you think that might mean? Okay, excellent. There's a starting donation of $3. Absolutely correct. So this is 3 on the graph. So before Monica walks anywhere, her sponsors are asked to give $3. So will you sponsor me in my walk? We're raising money for a charity. What I'm asking for is $3 from everyone that wants to help me out, and then there'll be a certain amount of money for each kilometer I walk. So that's a bit different, isn't it? You have a startup fee, almost like a beginning, an initial donation, we'll call it. Okay, that's what that means, exactly. So Sari didn't do that. Sari just said, I don't need anything up front. I'll tell you when I'm done walking how much you owe. But this person said, if you can give me $3 to start, then we'll calculate from there. So as far as an equation goes, let's try and build an equation here, just like we always do. So this is the same amount each time, it's plus 1. This is the same amount each time, it's plus what? 3 to 5, yeah, it goes 2, excellent. So 2 divided by 1 is what I multiply d by. 2 over 1 times d, and that's going to equal m. Now let's see if that's all we need. Well, I don't think it's all we need, right? We have to make an adjustment here. So let's take one that's not 0. We could do 0, I guess. So 2 times 0, does that equal 3? Nope. What do I have to add or subtract to get 3 from 0? Plus 3. Now let's check and see if this equation now works for the other ones. So 2 times 1 plus 3, does that equal 5? Yes, it does. 2 times 2 plus 3, does that equal 7? Yeah, that's 4 plus 3 is 7. So this is looking really good. 2 times 3 is 6, plus 3 is 9, and excellent. We have confirmation here that we have the right equation. So m equals 2d plus 3. That's the equation. And in words, we would describe this as, well, we would say that, actually I'll type this because it's a little bit easier for me to type. But Monica is asking, like we've already determined, Monica is asking for an initial donation of $3. Monica is asking for an initial donation of $3. And how much is she asking for every kilometer that she walks after that then? She's asking for $2 for every kilometer she walks. So let's finish that off. And $2 for every kilometer she walks. Okay, thank you. That is absolutely correct. So let's take a look at the graph, and we will be able to see that, you know what, the slope of this line is 2 units. It's 2 units, and we'll talk more about that later. But look at this plus 3, isn't that interesting? We learned yesterday that there is a form of a line that is y equals mx plus b. Remember that from yesterday? And we said that m was the slope of the line, which this is the slope of the line. It's a slope of 2. And what was b again? What was b from yesterday? Anybody remember? It was the y-intercept. Okay, so we have the slope here, and we have the y-intercept. And look at that. This graph intercepts the y-axis at 3. Okay, so what I want you to notice is that the description of this situation is connected to both the graph and the equation. Okay, an initial donation of $3, that's right here. $2 for every kilometer, that's right here, the slope. Okay, that's the rate at which she is earning money for every kilometer. $2 every kilometer. Okay. All right, one more. Actually, I'm going to get you to do this one on your own. I'll give you about 3 minutes, maybe 4 minutes. We'll see how long you need. But I want you to take a look at this, at Bruce's situation. Knowing what you know, go ahead and give that a try. And if you can't see, this is up by 2 over here. So 2, 4, 6, 8, 10, and 12. And this is each kilometer is 1, 2, 3, 4, 5. Okay? Here's your table of values. So determine the equation, write it out in words. I'll give you a few minutes to do that. Go ahead. All right, I'm going to do this real quick. Hopefully you've had a chance to give this a good shot. See if I'm doing this right, okay? This is how I would attack this. So as far as the equation goes, I would make sure that the difference between these values are the same. They are. It's all plus 1. The difference between these values are the same as well. They are also plus 1. Okay. So that means that I've got 1 over 1 times d. That's how I start my equation, and that's going to equal m. Okay. Now, does that fit if I test some points? So 1 times d, does that equal 5? 1 times 0 is 5? Nope. I would have to adjust that by adding 5. Let's see if that works for the other ones. 1 times 1 plus 5, does that equal 6? Yes. 1 times 2 plus 5, that equals 7, correct. 3 plus 5, 4 plus 5, very good. So my simplified version here would be just d plus 5. Don't even have to put the 1 as a coefficient. So m equals d plus 5. Now, describe, Bruce, how he's collecting money. So it looks like he is looking for an initial donation of how much? $5. Right on. So initial, if I could spell, initial donation of $5 or 4%. $5. And then, how much per kilometer? $1. Yes, $1 per kilometer. Okay. Okay. Does everyone see that? Any questions about that? All right. Which do you think would be the best? Which do you think would be the best? Would raise the most money? And how would you know, or how would you start to decide that? Okay, got a couple hands. Go ahead.
It depends on like how good you are at running or walking.
Okay. It depends how far you go.
Yeah.
Yes. Okay. So you think that each different plan is going to have a different dollar amount at a certain kilometer. Okay. So we could test that pretty quick, I suppose, right? But did you have anything else to say? No? Okay. So if you graphed, okay, so here's a couple ways that I would say this would be a good way to decide about this. If we were to graph each of these lines on the same grid, you would be able to see, all right, and maybe we'll even do this, but you would be able to see the rate at which you're charging. We can know this. This is $4 per kilometer. This is $2 per kilometer. $1 per kilometer. Okay, but you would also be able to see at what distance, the plans maybe would earn about the same amount of money. Like wherever they cross. Okay, because they'll have different slopes, so they're going to cross at some point. So wherever two of them cross, that's the distance that they would earn the same amount of money. So it depends how far you're going to walk. If you're going to walk for 2 kilometers only, you could run some quick numbers here. 2 kilometers, let's see, that would be $8 for this one. Okay, it would be $8 over here, 2 kilometers. 2 kilometers here would be 2 times 2 is 4 plus 3 is 7. So $8, $7 for this one. And then for this one, 2 kilometers would be also 7. So look at that. These two earn the same amount at 2 kilometers. Now, what if you were going to go 10? Okay, you're going to go 10 kilometers. Well, that's $40 as we mentioned before. What about this one? That's only $23. And what about this one? 10. This is $15. So yeah, it really does depend on how far you go, because they're all pretty much the same at 2 kilometers. So if students are only walking 2 kilometers, it doesn't really matter which one of these. They're both about the same. But if you walk that full 10 kilometers, then we definitely have a difference in what they owe. Okay. Okay. So here are roughly all three on the same grid, and when you put them on the same graph, you can see roughly which is going to be the best plan. So obviously at 10 kilometers, the black one is going to be this first option, is going to make you the most, like we just mentioned. And then somewhere around here, around 2 kilometers, you see how they're very much the same. They're very much the same. So that's anything over 2 kilometers, there's a difference. Anything around 2 kilometers, each of these would be the same. And that might be very important if other students in the class are deciding, how they're going to structure their donations, right? So there would be 3 options, let's say. and depends how far you're going to walk. If you're only going to be able to go 2 kilometers, it doesn't matter. If you're going to go 1 kilometer, you want to pick maybe the blue one, right? Because that's, or the blue or the red look about the same. If you're going to go over 2, you want to take the black option there, the first option. All right, let's move on here to the next page of your notes. Okay. This is actually at the bottom of your page of notes, which is great, but we already did the equations, right? So there you go. We did the equations already. So Monica, this one was Monica's. This one was Sari's here. And if you haven't done that yet, let me just help you. So that's Monica. This is Sari. And this is Bruce. Good old Bruce. Okay. Any questions about that? No? You good? All right. Okay, so let's continue on with this, matching equations with graphs. Now we're on the second page here. Okay, so the 3 graphs below have the equations listed here, but the graphs are not in the right order. So to match each equation with its graph, use the equation to determine coordinates of 3 points, then find which graph passes through these points. So that's the way we're going to attack this. And we will examine both the slope and the y-intercept of these equations because they're in y equals mx plus b form. And we'll be able to identify the graphs that way as well. Okay? So let's do this fairly quickly. We don't have to spend too much time on this, but you are going to substitute x equals -2 here. So follow along, write down what I write here. This will be how you show your work. Y equals, that's -4 minus 3, y equals -7. So we have a point that's the given x value of -2 and the calculated y value of -7. Moving down we'll go down the column here. So 2 times 0 minus 3 is going to be 0 minus 3, y equals -3. So we have a point 0, -3. I'm going pretty quick here, but hopefully this is understood. I really don't think I need to spend too much time teaching what I'm doing here. So again, I'm going to substitute +2 in for x, and I'm going to calculate what that y value is. That's going to be 4 minus 3, y equals 1. So we have a point of 2, 1. All right. So where do you see those points down here on these 3 graphs? Let's see if I can get down there. I'm going to just shrink this down a bit so we can see all 3 graphs. Oh, what's happening? Okay, so 0, -3 is a pretty important one. That's probably pretty easy to... Okay, this page doesn't like me today. Let's see. Let's go to the next page, and let's back up, and now let's see if this is going to work. Please? Okay, so where do we have a point 0, -3? That's the easiest one to spot, I think, because that's the y-intercept, isn't it? So where is 0, -3? I only see it in one spot here. Graph B right here, 0, -3. You see that? That's the y-intercept. Are the other points there? 2, 1. Yeah, looks like 2, 1 is there. And then -2, -7. So -2, here's -2, and -7 goes all the way down there. That looks about right, yeah. So this one is graph B. Everybody see that? Everybody see that? Yeah, okay. Okay. Now, I mentioned that the y-intercept is pretty important, and if you look at these 2 graphs, these have a different y-intercept, don't they? This one looks to be 3, I think. 1, 2, 3, yeah. This one is a y-intercept of 3. Okay, so 0, 3 is the y-intercept point. And this one, the y-intercept, is what? 0, 0, the origin. Yes. Okay. So I'm going to use that knowledge, and I'm going to go, you know what? I'm going to check y equals 0 first. Let's see what y equals 0 gives us over here for equation number 2. So that's going to be -2 times 0, y equals 0. Oh. So this has the point 0, 0 on the graph. So guess what? Right away, you know which graph this is. It's graph C. So you can use your intuition, use your reasoning. Now we are going to fill in the rest of these values just to double check, but that's a way that you can determine the answers to questions by thinking ahead. Okay. So y equals -2 times -2, that should be y equals 4. So if x equals -2 and y equals 4, that's the point -2, 4. And of course over here, we have the point +2 and -4. So does that match up there? Let's see, -2, +4, -2, +4, you bet, right there. And +2, -4, right on, right there. So that definitely is graph C. Any questions? Okay. Here's the third way of doing this, okay? So remember what we said about this equation. The form, or the format, is y equals mx plus b. That's the format that this equation is in. I have a y on one side, I have an equal sign, then I have a number times x, and then I have adding 3. Now, if this is a plus or minus, it doesn't matter, it's still in this form. You could be adding a negative number. But this is pretty easy to see. What is my slope? The slope, or m, is 2. That's the number that's attached to the x there. And what's my y-intercept, or my b value? It is 3. So, graph A, we know that that's the answer, but let's double check. A y-intercept of 3 is perfect, right there. The slope of 2. Now, we haven't really done this yet, but I don't think we've done this in class yet, but how does the slope in the graph, how does that work? Well, remember what we did with the table of values. The constant change in y, remember on the right side, the constant change in y divided by the constant change in x. So slope is how the vertical change happens divided by the horizontal change. Have you ever heard of rise over run for slope? Anyone ever heard that before? No? Okay, all right. Well, it'll come up again, but if you have a slope of 2, that's the same as 2 over 1. So if you remember with our table of values, that's how we calculated what the number is that multiplies by the x there. So what does m, or slope of 2 over 1, mean? Well, it means the change in, and there's a little triangle. That's the Greek letter delta. The change in y values divided by the delta change in x values. That's what slope really is. And that's what we've done in our table of values. Just like, we did over here, right, with all of these. The change in the y values divided by the change in the x values. 1 divided by 1 gives us 1. Almost done. So from the graph, this is how you would work this. Watch this. A change in y of 2. So I would go from this point, I would go 1, 2 units up, and then I would go 1 unit, which here's 1, I would go 1 unit over. So 2 over 1 gives us the next point on the line. Guess what? 1, 2 over 1 unit, because we go from 1 to 2, it's spaced a bit differently down here. That gives us the next point. 1, 2 over 1 gives us the next point, and so on. So that's how you connect the graph and the slope. Okay? And then you connect all those points and extend the line. So those are some tools for your toolbox there to identify equations and graphs and the parts of them. Let's just finish this real quickly here. For equation 3, we'll fill in these values here real quick. So do these points match up with the graph? -2, -1, 0, 3, 2, 7. Let's see. 0, 3, 2, 7. And what was the other one? -2, -1. Yeah, -2, -1. That's right there. All right. Any questions there? You guys have been very patient. You listened very carefully. I really, really appreciate that. Okay, so this one is A. Now, hopefully you have a bunch of tools here to be able to figure this stuff out, connecting graphs and equations. I'll give you your 4.4 assignment here. 4.4 assignment is 1 to 13. 1 to 13. That's it? Yeah, that's it. Are you complaining? I can give you more.
No, I was just curious.
You can do 20 to 50 as well. You can do extra 30 questions if you complain.
Do I get extra credit?
Sure.
You're gonna do that for extra credit?
No, I don't think those questions exist even. All right, so that's the assignment. Any other questions?
What page is it on?
4.4, page 188. Yeah.